What's going on, everyone? So we got a new topic here in this video, which is volume. Okay, so we're going to be looking at volumes of prisms. Okay, now a prism is essentially an object that has, some shape for its bottom, and then we would basically raise up all the sides and we would have the same shape for the top. Okay, so it's like taking something flat and then just lifting it up and then putting straight sides all around. So there's a pretty simple formula for areas of prisms, volumes of prisms. The volume is equal to the base area times the height. Okay, so if I can figure out, how much area I have here on the base or the bottom of the figure, right? And then I multiply it by its height, then I can get the volume. Now, these two problems here are a little bit tricky because of the orientation of the object, right? So the object is not drawn so that the base and the top are the same shape, right? So, so what I want to do is I just want to redraw this figure, okay? So I can see that I have a right triangle here, and in the back of the figure, there's another right triangle, okay? Those right triangles should be the bottom and top of my figure. So I'm going to do my best to draw a triangular base. Okay. Lift it up. So we have a triangular top too. Okay. So it's the same shape, and now we just have to match all the lengths. Okay. So for the triangle, we have an 8 centimeter length for the long leg. So that's 8 centimeters there. We have 5 centimeters for the short leg. So I can put the 5 there. And then the distance connecting one triangular face to the other triangular face is 3, right? So this distance here is 3 centimeters. All right. So what we want to do is we want to find the area of the base. And because it's a triangle, right, we should all remember what that formula is. And then we'll multiply that by the height. Okay. All right, so the volume equals the base area, which I've shaded in green, times the height. Okay. Now for a triangle, right, the area of a triangle is 1/2 base times height, but I'm going to do length times width just to not confuse it with the vertical height of our object. And then we'll times it by the vertical height. All right, so that's going to be 1/2 times 5 times 8 times 3, right? The length and width are 5 and 8. All right, so let's go ahead and compute this. 1/2 times 5 times 8 times 3 is 60. Okay. Now the linear units are centimeters, right? The area units would be centimeters squared. Area has 2 dimensions, so volume has 3 dimensions, so the units are going to be centimeters cubed. All right, cool. All right, next figure. Looks like we have a trapezoid on the front face and a trapezoid on the back face. Okay. And so we're going to want to kind of redraw this. But, do you know how to find the area of a trapezoid? Maybe, maybe not. So here's something else we can do, right? Let's divide the trapezoid into a rectangle and a triangle. Okay. So now what we have is we have a rectangular prism and then a triangular prism that are just fused together. So think of it this way. We have a rectangular front face and a rectangular back face. Okay, so that's one prism. And then we have a triangular front face and a triangular back face, right? That's our triangular prism. All right, so let me try to redraw these. Okay, so I'll just draw a rectangular base. And a rectangular top, okay? So I'll shade just the bottom base this time. Okay. So what are the dimensions of this rectangular base? Well, if I look here in the original figure, right, from on the top here of the rectangle, that's 4.4. So that's the long side. And then here is 2.5. That's the shorter side. Okay. And then the distance from one rectangular face to the other is that length there, which is the same as that length there. So that's 4.2. It's going to be a little bit more challenging for me to draw the triangular prism, but I'll try. Okay, so we're going to have, okay, let's try. Okay, so there's the right angle. And then we're going to lift up all the sides. Okay. All right, so let's just shade in maybe the bottom face. All right, so we know that the distance from one triangular face to the other is 4.2. So I can label this height here as 4.2. Okay. What are the dimensions, the length and width of the triangle? Well, since this is 2.5 meters here, the long leg of the triangle will be 2.5. Okay. The short leg, we got to do a little bit of math, right? So it's 5.6 from point to point, from end to end, okay? And then we know that it's 4.4 just for the rectangular face. All right, so if we take the difference of 5.6 and 4.4, right, so let's write 4.4 is that distance. So the remaining distance is going to be 1.2. So we can write 1.2 as the other dimension for the triangle. Okay. All right, so we're going to find the volume of the rectangular prism, the volume of the triangular prism, and because they're fused together, then we can just add the two volumes together. All right, so the volume is the base area times the height. Well, because it's a rectangle, that's just length times width for the base area times height. So 4.4 times 2.5 times 4.2. Okay, let me calculate that. 4.4 times 2.5 times 4.2. 46.2. Okay, and then for our triangular prism, again, the volume is the base area times the height. But because it's a triangle, the base area, the formula is 1/2 length times width, okay, times the height. So that's going to be 1/2 2.5 times 1.2 times 4.2. 1/2 times 2.5 times 1.2 times 4.2. Okay, we get 6.3. Okay, so because the original figure we could think of as a rectangular prism fused with a triangular prism, and we calculated those volumes separately, now we'll just add them back together. And so the total volume is going to be 52.5, right? 46 and 6 is 52. 0.2 and 0.3 is 0.5 meters cubed. Okay. volume has 3 dimensions, so the units are cubed units. All right. Thanks for watching, guys.